Arg! Welcome to lesson 16, folks. Let me ask you a question. What's the pirate's favorite letter? You'd think it was the R, but it's actually the C. All right, enough with my bad dad jokes. Let's get on to lesson 16. Today's lesson is going to actually be the concept development video plus the problem set. We're going to do them together because we're going to be working on using our decimal skills through our word problems. So today, we're going to need the application problem out of your workbook and your problem set for lesson 16. So go ahead and press pause if you need to get those materials out. Again, you'll need the application problem and the problem set. All right, so now that you have those materials, I'm going to skip this into the next page. I typed it into Active Inspire today so that we could work with it. You guys have the paper copy. So let's get started. Let's read it together. And we're going to follow the read, draw, write model. So we're going to read it. We're going to draw a tape diagram to help us understand what we're looking for. And then we're going to solve for it. So the way I think about the tape diagrams after we read this is it just helps us understand critically what we're doing with the word problem. So let's go ahead and think about this. Jesse and three friends buy snacks for a hike. They buy trail mix for $5.42, apples for $2.55, and granola bars for $3.39. If the four friends split the cost equally, how much should each friend pay? So the first thing we're going to need to know is how much all of those items cost together, right? Before we can equally split it up. So first I'm going to make a tape diagram because we do not know how much all of these items cost together. So first we have our trail mix. I'm just going to abbreviate that as TM, trail mix. And we have that as $5.42. And then we have apples. I'll just abbreviate that by the A, sorry. And that was $2.55. And then granola bars, and I'll abbreviate that with a GB, was $3.39. We do not know what that cost altogether. So altogether, we added these three boxes up. We do not know that cost. So that's a question mark. But once we solve for that, we're going to then, that same tape diagram, we're going to do the same size because it should be the same value. We are actually going to then divide that value up into fourths, right? And we don't know how much, because there's four friends, and we don't know how much each friend is going to do. So this right here is the cost for one friend. I ran out of space below. So that's the cost for one friend. So now that we've done the tape diagram, it didn't take too much time. It helps us understand the steps we have to do. The first step up here, we're going to have to add these three decimals together. And then we are looking to divide it into four equal groups. So let's go ahead and get started by stacking them. Remember, when we stacked our numbers to add or subtract, we want to make sure that we're lining up the place values. The best way to line up the place values, in my opinion, is to use that decimal to help you. And then make sure you're writing nice and neat so that the values line up over top of each other. And then once you have that, I'm going to change color just so that we can see my regrouping. 2 in the hundredths place, we got 2 hundredths plus 5 hundredths, 7 plus 9, that's 16. 4 plus 5 tenths is 9 tenths, plus 3 more tenths is 12 tenths, plus 1 more is 13 tenths. The decimals come down. 5 ones plus 2 ones is 7 ones, plus 3 more is 10, plus 1 more is 11. So altogether, it would cost $11.36. Okay, well, let me move down and give myself a little bit more space. Now we're not done because we need to then take that $11.36 and we're going to divide that by four equal groups. Can I scroll down anymore? Oh, that's as far as I can go. What happened to my work. All right, there we go. That was weird. Computer was glitching out. All right, so I'm going to solve this using the standard algorithm. I'm going to look to my largest place value. There's 1 in the tens place. Can I divide 1 into 4 equal groups? Nope. So let's represent that with a 0 above. Actually, let me change colors so we can see the work I add in there. Let me go to yellow. We cannot do any tens. We cannot divide any one of those tens into the 4 groups equally. So we didn't pass out any of those tens. So we have 1 remaining 10. We're going to bring down the ones so that we can decompose that 10 into ones. And now we're dealing with 11 ones. If we're working with our multiples of 4, 4, 8, 12, well, we can do 2 multiples equally. So we can have 2 in each of those groups. So 4 groups of 2 gives us 8. We should have 3 remaining ones. Now, let me just, I already know I'm going to run out of space, so let me just shrink this up a little bit. Oh, man, I didn't really want to grab the work above it. There we go. Now we've decomposed. Now we need to decompose into the tenths place. Let me put my decimal up there. Now I need to decompose into the tenths place. And now we're working with 33 tenths. Now, knowing my multiples of 4, I know one of my multiples of 4 will get me to 32. And that's 4 groups of 8. It's really important that we start mastering those multiplication facts if we haven't already, our multiples, because it really helps make division simpler. Now we should have 1 remaining hundredth or tenth, so now we need to decompose into our hundredths. So we're now working with 16 hundredths. Again, knowing our multiples of 4, 4, 8, 12, 16, that's 4 groups of 4. And then we're left with 0 remainers. So that's our quotient, that's our answer. So each cost of each friend is going to cost us $2.84. So now we need to put that into a statement. So each friend will pay $2.84. Perfect. All right, so now that we've warmed up with that application problem, we are going to move on to our problem set. Now, at any point that you feel like you want to challenge yourself, please press pause and move on to, or try the part of the problem, and then check your work, and then keep doing that. Keep pausing, moving forward one problem, and then checking your work with me. So I'm going to go ahead and put my name on the paper, and I'm going to change color because I want to be able to see my work. And we're going to do the same steps: read, draw, write. We're going to read it. We're going to draw a little tape diagram to represent our problem. And then we are going to write a statement after we solve the math. So let's see. Mr. Fry distributed $126 equally among his 4 children for their weekly allowance. How much money did each child receive? So let's go ahead and make a tape diagram really quick. We know that altogether, Mr. Fry gave us $126, or gave his 4 children $126. So we know that there's 4 kids, but we don't know how much each kid received. Okay, so we know now that we need to divide. So 126, we're going to divide that by 4. Now remember, because I can already see it, we're going to have a decimal situation where we're going to have to, regroup into our tenths place. So let's just keep that in mind as we're solving this problem. So let me change color so we can easily see my work. And we're going to start with the tens or the hundreds place because we start in the largest place value when we divide. And we see that there's 1 in the hundreds place. Well, we know that we need at least the same as our divisor to be able to divide equally for 1. So we know that we cannot do this. So we're going to represent that with a 0. We're going to say we can't pass out any of those hundreds equally to our 4 groups. So we're left over with 1 remaining 100. Now we're going to decompose that into our tens place. So now we're dealing with 12 tens. Well, 4 divided by 12, or sorry, 12 divided by 4 tens, 4, 8, 12. 4 groups of 3 gives us all 12 of those, so we have 0 remaining tens. But now here's our ones. We had to decompose all the way down to our ones. And this is what I was talking about. There's 6 we're dividing into 4. And we know 6 isn't a multiple of 4, but 4, 8, right? So we know that we can have 4 groups of 1 out of 6, and that will leave us with 2 remaining ones. And this is why we need to decompose into our tenths place and bring down our tenths place. So now we're decomposed it, and now we're dealing with 20 tenths, which is a multiple of 4, 4, 8, 12, 16, 20. So we're dealing with 4 groups of 5, and that will give us 0 remaining. So each child should receive, here's our quotient up here, right? So that's our answer. So each child received, make sure you use the unit, the symbol for dollars, so that we know we're not talking about 31.5 bananas. Each child received $31.5 or $31.5 or 31.50. All right, so let me just shrink this up. So, whoa, oh, I hate this sometimes. Let me lock this. All right, let me shrink this so I can actually do work in the other space. All right, so now we're on to B. It looks like, so now I can see this, when they do stuff like this, we know that this problem is going to work off of the problem we did up here. So John, the oldest child, paid his siblings to do his chores. That was really nice, and maybe potentially smart, depending on how much. If John pays his allowance equally to his brother and 2 sisters, how much money will each of his siblings have received in all? Oh, this is important. Received in all, not just from the brother, but it looks like they're asking in all. So on top of their allowance plus the share of their brother. So we know that each child made $31.50. But the oldest brother is like, I don't really feel like doing that work. I'm going to split that between my 3 siblings, 1 brother, 2 sisters, right? But we really don't know how much that's going to be. We don't know how much that's going to be. Let me really quick. I need to take Bronson out. All right, sorry about that. Bronson needed to go outside. Let's get back into this math problem. So we know we're dividing $31.50 into 3 groups. So we need to divide 31.5 divided by 3. Let me change colors so it makes it easy to see the work. Well, again, we always start into the tens place, the largest, I shouldn't say in the tens place. We always start in the largest place value, which in this number, our dividend is tens place. Our divisor is 3, so we see that this dividend is the same number as the divisor that we're working with in this place. So we know that we can divide it. We know that 3 divided by 3, we can do that equally once. So 3 groups of 3, we use all 3 tens, so there's no remaining tens. Now we bring down our 1 to decompose. 1 divided by 3, well, we can't equally divide 1 into 3 groups without decomposing, so we're going to go ahead and put the 0 up there and show that we cannot divide any of those down below. So we have remaining 1, and we're going to decompose that into tenths. Well, there's 15 tenths. I'm going to make sure my decimal follows the quotient up top. Well, 15 is a multiple of 3, 6, 9, 12, 15. That's 3 groups of 5, and that gives us 0 remaining. So each sibling is going to get an extra $10.50. But we need to check to see what that is on top of the money they already received. So each sibling gets $31.50 already, and we're going to add $10.50 to it. And we can see that when we do this, whoops, I messed up. I need to regroup the one over here. 1 plus 0 plus 1 is 2. 3 plus 1 is 4. Each child now should get 42, or each of the siblings, right? Not each child, because John's giving it away. Each sibling will get, not a bad deal for those 3 siblings. And maybe, it depends on how much time John gets back, maybe not a bad deal for him either. But each sibling will get $42 now. All right, so again, I'm going to shrink this just so that I can work on question 2 with you without getting this in our way. All right, so shrink that, perfect. And now we're working on question 2 about Ava. All right, again, following the redraw right method, we're going to be looking to draw a tape diagram to help us understand, solve it, and then write a statement about it. So Ava is 23 centimeters taller than Olivia. And Olivia is half the height of Lucas. If Lucas is 1.78 meters tall, how tall are Ava and Olivia? Express their heights in centimeters. So remember, we got to remember that 1 meter equals 100 centimeters. So that's just something that we have to remember so that we can solve questions like this. So that means 1.78 meters is really 100 centimeters plus 78 hundredths of a meter, which would be 78 centimeters. So this should be really 178 centimeters. So now that we've converted that, let's go ahead and draw a tape diagram real quick. So Ava is taller. So this is Ava. Ava's taller than Olivia. So Olivia's tape diagram should actually be shorter, a little smaller. And we know that Ava is 23 centimeters taller than Olivia, or we could represent it like this. This is 20, whoops. This is 23 centimeters. But Lucas and Olivia is half the height of Lucas. So this is, okay. So Lucas is double of what Olivia is. So we know that if Lucas is 1.78 meters tall, we know this whole thing is 1.78 meters, or 178 centimeters. And we know Olivia is half of this, right? So to get Olivia, what do we need to do? That's right, we need to divide Lucas's in half. So let's divide 178 divided by 2 really quick, because they want it in centimeters. We can do that. We cannot do the hundreds place, so we'll represent that with a 0. Divide, subtract, we're left with 1 remaining 100. Decompose into the tens place, 17, 2, 4, 6, 8, 10, 12, 14, 16. I know I can do 8 groups, 2 groups of 8. So that will leave us with 1 remaining 10. Bring down our 8 ones. That is a multiple of 2. 2 groups of 9 gives us 18. No remaining. So we know that Olivia is going to be 89 centimeters now, because she is half the size of Lucas. To get Olivia's size, or sorry, not Olivia. I had students Olivia and Olivia in the same class. To have Ava's size, we need to add back that 23 centimeters to our Olivia's size, and we should have 12. 8 plus 2 is 10, plus 1 more is 11. So we know Ava size is 112 centimeters. Perfect. So how do they want us express their heights in centimeters? So let me just change colors because I ran out of space. So Ava is 112 centimeters and Olivia is 89 centimeters. Sorry, that got crammed, but that's the answer. Perfect. All right, let's move on to the back side. And we got, oh, sorry, there's actually 2 more pages. Let's go ahead and work on question 3. Mr. Howard can buy a computer with a down payment of $510 and 8 monthly payments of $35.75 if he pays cash for the computer. Oh my goodness, so actually, let me pause this real quick. So what I was trying to decide when I was pausing there was how much work I would really want to do. Let's skip 3 and 4. Let's skip the second page and let's go right to the last page because this is the hardest problem of this lesson. So let's do this last side. If you want to do questions 3 and 4 for some extra class craft points and take a picture and submit it inside of the exit ticket submission, do it. Also submit your exit ticket. I'll be able to see both. And if you do that, I'll give you extra credit, class craft points, for taking some initiatives to be the best you that you can be in your math. But to make the lesson go a little bit smoother or faster and not torture you so much, let's go right to question 5 and do this together. All right, so the bakery bought 4 bags of flour containing 3.5 kilograms each. 0.475 kilograms of flour is needed to make a batch of muffins, and 0.65 kilograms is needed to make a loaf of bread. Okay, that's a lot of information, right? So we need to, we read it once. Let's go ahead and read it again because that was a lot of information to kind of take in. So the bakery bought 4 bags of flour. Each bag of flour contains 3.5 kilograms each. Okay, so total, that's the total amount of flour we have. Okay. And then we know that 0.475 kilograms of flour is needed to make a batch of muffins, and 0.65 kilograms is needed to make a loaf of bread. Okay, so we know how much flour we have total in this section, right? And then these are like our ingredients or the amounts that we need for the recipes. So let's start working on this. So if 4 batches of muffins and 5 loaves of breads are needed, how much flour will be left? Well, first we have to decide how much flour we have. Well, we have 4 bags of flour, right? 1, 2, 3, 4, and each of those bags of flour has 3.5 kilograms. This is our flour. But we don't know how much we have altogether. So let's go ahead and solve that. We know that 3.5, or let's convert this into 35/10 to make our math a little easier, times 4 groups. Well, 4 times 5, keep our unit down here so we remember. 4 times 5 is 20. 4 times 3 is 12, plus 2 more is 14. So 140/10 really is equal to 14.0, but we don't have to show the 0.0. So let's just show it as 14. So now that we know that this is actually equal to 14 kilograms, now we can start figuring out how much muffins and loaves of bread we can bake and how much flour we'll have left. So we know that we need 4 batches of muffins. We have a muffin batch and we have a bread batch, and then we want to know how much is left, right? So muffins, we're going to do 4 times, well, let's look at the recipe. It says 0.4 0.75. And then the bread needs to be 5 loaves of bread times 0.65. This is a very involved problem. So it's very important that we go back and reread the question and look for that information. And we do not know how much flour is left out of all that. So let's go ahead and first solve for this part so that we can then subtract from our total 14 kilograms. So let's solve for our muffins, how much flour we need for our muffins. So this time I'm not going to, well, I'm not going to convert it to unit form, and I'm just going to do standard algorithm with the decimal there. We know that there's 3 decimal places after, so we're talking about thousands. So we still need 3 decimals places after the decimal for the answer, for the product. 4 times 5 is 20. 4 times 7, 28, plus 2 more is 30. 4 times 4 is 16, plus 3 more is 19. 4 times 0 is 0, plus 1 is 1.90. So this is actually equal to 1.9. And then we can do 0.65 times 5. Again, I'm not going to convert into unit form this time, but I do notice that it's hundredths, so my answer still should show hundreds. 5 times 5 is 25. 5 times 6 is 30, plus 2 more is 32. 5 times 0 is 0, plus 3 more is 3.25. So we know that this is 3.25. Let's go ahead and add that together. 3.25 plus 1.9511. This is why we want to get fast at our math facts. So we know that altogether for muffins and bread, it takes 5.5 kilograms of flour, but it wants to know how much flour is left. So now I'm going to change colors so we can see this math. 14.00 minus 5.15. So we need to regroup right away. Let me change colors again so you can see my regrouping. I don't have any values all the way until the ones place, so I can regroup from the ones. Now I'm working with 10 hundredths, regroup from that to give myself 10, I should have said 10 tenths, regroup from the tenths to give me hundredths. 10 hundredths minus 5 hundredths is 5 hundredths. 9 tenths minus 1 tenth is 8 tenths. Okay, I need to regroup here for my tenths place to give myself ones to work with. 13 ones minus 5 ones is 8 ones. So the answer is 8.85 kilograms of flour will be left. All right, let's see what we can do down here. The remaining flour bin is stored in bins that hold 3 kilograms each. So we know that each group has 3 kilograms, but we don't know how many groups we'll need. We know that we have 8.85 kilograms to work with. So we need to divide 8.85 divided by 3. I'm going to change colors so we can see the math work. Well, we're in the ones place because it's the largest place value. So 3, 6, 8. We can do 3 groups of 2 out of that, right? Equally, which leaves us with 2 remaining ones. Put my decimal up. Let's bring down our tenths to decompose it. Oh, 3 groups of what gets us close to 28? Well, 3, 6, 9, 12, 15, 18, 21, 24, 27. Yeah, 3 groups of 9, 27, which gives us 1 remainder of tenths. Bring down our 5 hundredths. 3 groups of what? 3, 6, 9, 12, 15. Yep, 3 groups of 5. That gives us a remainder of 0. Oops, I ran out of room. So how many bins will they need? Well, we need 2.95 bins. Well, can't really have a fraction of a bin. So we need to round this to the nearest number? Well, we need 3 bins, right? So how many bins will be needed to store the flour? 3 bins will be needed to store all the flour. We couldn't have 2 bins, right? Because 2 bins wouldn't be enough. 2 bins would only hold 6 kilograms. So that is today's lesson. Nice job. And we will go ahead and move on to your exit ticket. Submit that. And again, if you want extra credit, class craft points for doing questions 3 and 4, go ahead and submit a picture of that as well. And then you'll be done for the lesson for the day. Good job.